I hope we came into consensus as to what the major difference between divergent and convergent are, because it really needs to make sense to you all before you really kind of dive into this. So before I put any equations down or things like that, I just want to talk to you about the effects of the ratio, the common ratio, as we're going through here. So I'm going to do a couple of these just to kind of give you an idea of what is going on here. All right, and this is dot, 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 dot. And it goes on forever. I should have put plus here. All right, so this is an infinite sum, and it's infinite sum because it goes dot, 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 dot. So this is going on forever. And you know by looking at this that r is going to be equal to 2, because it's 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so on, and so on, and so on. The issue with this is I want to know the sum of the whole thing. Now, all these numbers are getting bigger and bigger and bigger and bigger and bigger and bigger and bigger. So, as we're summing things up, what's the sum doing? It's getting larger and larger and larger and larger as we add those numbers. Huge. Really large. So this thing is getting humongous because we're keep adding and adding and adding and adding and adding and adding and adding. So now let's try something else. Let's try 4, 2, 1, a half, a fourth, eighth, and so on, so on, so on. Oops, I need to put plus signs here. I always forget that. I'm supposed to be putting plus signs here versus. Alright, so we have all these pluses. I don't know if you can read that or not. It might be not worth it to. Hold on, let me just rewrite it again. It's just easier. Okay, so let's try this again. 4 plus 2 plus 1 plus a half plus a fourth. Dot, 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 dot. Alright, my brackets need help, I know. But writing on plastic with a plastic point is not that easy. Alright, so what's going on with this? Well, this is 4 plus 2 plus 1 plus 0.5 plus 0.25 plus, if we keep going, this would be 1.25. And then it gets, so this number, what is happening with this number? It's getting smaller and smaller and smaller as we keep going. Well, when it comes to the sum, this sum is only going to get, so large, and then it's going to, as each number is being added to it, it's only going to move a tiny, tiny bit. Like right now, this is, what is it, 6, 7, 7.5, 7.75. All right, we're at 7.75. And then I have to add in this. You notice I'm not even over 7 yet. So each time, now if I add the next one, I don't even know what that is, but if you add the next one in, this is going to be even a smaller decimal. So that 7.8 is hardly going to move, because each consecutive time I do this, the decimal is going to get smaller and smaller and smaller and smaller, which contributes less and less and less to the sum. So at some point, the sum is only going to get so big, and then it's going to move in such microscopic movements that you're not going to be able to tell what's going on. And it happens with the negatives too. I mean, don't let the negatives fool you either. So if you had a problem where it was going -4 plus -2 plus -1 plus -1/2, it's the same problem. I mean, I shouldn't say the same problem, but okay, so now instead of being a positive number, it's now -7.75, and all the math down here. So yes, it's getting smaller and smaller and smaller and smaller and smaller, but it's what these things are doing that's the important part. So we have to show that as these numbers are getting really smaller and smaller and smaller and smaller and smaller, it's contributing less and less and less to the sum. So that's why they would be considered convergent. Where divergent, the first example I gave, okay, there's no limit to how big this sum is getting. Either, again, if these were negatives, it'd be a really, 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 really small, a really, really, really large negative, and a really, really, really large positive, depending on whether I have pluses and minuses in here. So that's divergent. There's no possible way I could come up with a sum. I couldn't figure it out because the numbers keep on drastically changing as we keep adding more and more terms to it. Where this, as I'm adding more and more terms, it's only moving the sum in smaller and smaller and smaller and smaller increments. So then I can kind of lock in, like I can lock in that this is probably not going to even make it to, it might make it to 8, maybe. Because again, the decimals are getting smaller and smaller and smaller and smaller and smaller and smaller and smaller. It might maybe get to 8.5. But we can actually figure that out using a formula. So that's what we're going to do next. So we're going to determine whether or not things are divergent and convergent, and then we're going to figure out if it is convergent, we're going to be able to use our formula and find the sum. If it's divergent, then we don't do anything, because there's no possible way to find the sum of a series that is divergent. So here we go.